Hi everyone. In today's challenge, we have this problem maximum twin sum of a linked list, right? And the problem number is 2130. Alright guys, so as usual, first of all, we are going to clearly understand what this problem says. After that, we're going to see the logic part. And after that, we are going to do the implementation part. We are going to implement our logic in C++, Java and Python programming language. Fine guys, now let's see what this problem says. Problem says in a linked list of size n, where n is even, the ith node of means a zero node of a linked list is known as not zero indexes. So ith node of a linked list is known as twin of n minus 1 minus ith node. So basically it want to say if we consider this particular linked list, so let's say 5, 4, 2 and 1. This is our linked list, right? So any of the node, let's say this is the node. So I'm going to take a different color. So if I consider this node, so this is zero node, right? And total n is nothing but 4 because they are 4 nodes. So its twin is nothing but n minus 1 minus I. That means n minus 1 minus 0, that is nothing but 3, right? So you can see this is the twin node of this because this is 0 indexes, 1 indexes, 2 indexes, 3 indexes. They have given that we have to use a 0 indexes, right? So for 0 indexes we can say this is the twin of this. 5 twin is 1 and 4 twin is 2 because 1 is this is a 1 indexes, so n minus 1 minus 1, that means nothing but 2, right? 4 minus 1 minus 1, which is come to 2, and 2 indexes is nothing but 2 only. So we can say this is the twin of this and this is the twin of this particular one, right? So this line is simply says that we what are the twins, right? After that we can say they have given the example as well. For example, if n is equal to 4, the node 0 is the twin of node 3, as we have already seen. This node 0 is the twin of node 3 and node 1 is the twin of node 2. Node 1 is the twin of node 2. Alright, so these are the only nodes with the twin of 4, n is equal to 4, right? Now guys, they told that a twin sum is defined as the sum of a node and its twin. So basically twin sum is nothing but we can say if 5 is having a twin 1, right? So the sum of both 5 plus 1 is nothing but 6. So twin sum is part of a node, this node is nothing but 6, and twin sum of 4 is nothing but we can say also 6, right? 4 plus 2 is 6. Even the head of a linked list with even length return the maximum twin sum of a linked list. So now guys, they are given a linked list and there are even nodes. They will not be odd nodes because we can't find we will need to find then we can say twin of between nodes. Like if there are 5 nodes, so we if I make a more node here, so let's say 2 3 4 5 and 1 here, you can see that we can say twin of 1 is 5, 2 is 4, but twin of 3 is nothing but, right? We don't have a twin of 3. So for this problem we are not given an odd linked list, we are given only even linked list, right? So this is the problem. Now let's see the example first. So here they have given that this is a linked list, right? So they are given this linked list, and in this linked list we have to find the maximum, return the maximum twin sum, right? So for 5, what is the twin sum? It is 6. For 4 also it is 6. So we can say the maximum is nothing but 6 only, right? So we can return only 6. I hope this is clear, right? Now if we take any more examples, so let me take another example. So let's say 2 7 6 and let's say 7, let's say 5, right? So will be the maximum twin sum will be 13, right? Because the twin sum of 2 is nothing but 2 plus 5 7, and twin sum of 6 is nothing but 13, right? So we can say maximum is nothing but 13, so we can return 13. So this was the basic problem understanding. I hope you understood the problem, because now it's the benefit to go to the logic part. If you don't have a clear idea on this problem, then you can write in the comment section, but you must to make sure that you are clear with this particular problem statement, right? So now let's see the logic part, how we can solve this particular problem. And first of all, let's think about brute force approach. And brute force is always going to be easy in this linked list part, right? We can use an array, we can use a lot of things in this linked list, right? So what is the brute force approach you are getting right now in your mind? Think about it. So for me, I am getting like what I can do again, I can store in an array 5 4 2 1. This is in my array now. And what I can do, I can say that just use a for loop and find out the sum. Very simple, right? I have used a loop. I can use a loop here. So what will we do? I will use a loop for half of the array, right? If n is, let's say the length of an array is n, so I will gonna traverse for n by 2, and I will gonna get the twin sum of every element, right? And I can return the maximum. So this is not, I would say, brute force approach, but this is not a best way, because if you have a linked list problem, you must solve with a linked list, right? Should not convert into an array, make it a array problem. So I hope you are getting it. Now, how we can solve this particular problem without using an array? Let's see that part. But what will the we can say the time complexity and space complexity brute force approach? So time complexity will be big of n, right? Because we are going to use traverse this over a linked list, right? And this will be n by 2, which will asymptotically become n. And what will be the space complexity? Space complexity will be big of n, because we are using a n size extra space. We are making an array. So we can reduce this particular space complexity if we go with the linked list, right? So let's see how we can do this. So optimize one, let's see optimize. So guys, what all we need, if I make it a little bigger linked list, so if I say this is 1, this is 2, this is 3, this is, let's say, 9, this is 5, this is 4. So this is our bigger linked list, which where we have 3 twin, right? Okay, now what we can do, we can say guys, what we can do, we can first of all we need to find the one, we need to find the twin sum of 1, which is nothing but 1 plus 4, then 2, 2 plus 5, then 3, 3 plus 9, right? So now guys, for every time we need this last, right? For this we need this one, for 2 we need 5, for 3 we need 9. I hope you are getting it, right? So why can't we make this particular thing a reverse? Because if I took and reverse it and write here it will become 4, 5 and 9, because the 9, 5, 4 is reverse is 4, 5 and 9, right? So if I do like this, then I can easily get the sum of everyone, right? Every twins, why 1, 4, 2, 5, 3, 9, I can easily do. So the main logic is here is that we have to reverse this half linked list. Yeah, or you can do the reverse of this particular linked list. So I can write here 1, 2, 3 reverse is 3, 2 and 1. Again I am getting the same thing, right? 9 and 3, 5 and 2, 4 and 1. So it's depend on you whether you want to reverse the first half or second half, right? So the logic is simple, that first of all find the half of the linked list, because as it is even, so we can easily find a half, and which will come to like either in this node, right? So once you find the half of a linked list, either you can reverse this particular part or you can reverse this particular part. And once you reverse it, just you need to traverse over a linked list, and you have to keep adding you can see the sum of both the linked lists. So let me give you a go through first. So let's say this is linked list, right? So let me do a go through so that you can understand easily and you can code by yourself without moving next, right? Okay, so let's say this is linked list. So what I'm going to do, I'm going to halve the first half, right? So I can say this was the, let's say, main linked list which is having a head, right? So what I'm going to do, I'm going to say head should be now pointing to 9, because I have done half. So head is pointing to now 9, fine. And let's say that this is has been reversed, so I'm going to store it in somewhere. So let's say reverse, right? Reverse is nothing but 3, 2 and 1, and head is nothing but 9, 5 and 4, right? Now I can say while head, or you can say while reverse is not equal to null, right? You can keep going here, and you can say sum is equal to your result is equal to should be maximum of earlier result, or you can add these two values. So head dot value plus reverse dot value, right? You can do like this, and after that you can move ahead. You can say head should be equal to head dot next, and reverse should be equal to reverse dot next. I hope you are getting this, right? So was just we are doing a half. I have done the first half and store in the another link. We can say some other linked list, or we can say like make it a new variable reverse, and I have the rest of the half. I've just used the traverse till the end, and while traversing I'm just keep adding the sum, and I'm just checking whether it is the maximum. If it is maximum, store the result, otherwise keep the my result as it is, right? And after that we will return our result. So this was the basic, I would say, the main idea of solving this particular problem. I hope you understood the logic. If you still have any kind of doubt, don't worry. By the code, you will definitely going to understand how we are solving this particular problem. So now let's move to the code and see how we can solve this particular problem. Well, let me make it a size bigger here. Okay, now I hope this will be fine, right? Alright, so let's take it first of all Python programming language this time. Fine, and first of all, what I'm going to do, I'm going to say half the first linked list, right? And why I'm doing the half of first linked list? Why not second? You will find it, right? So first of all, I need to make a slow pointer, which is pointed to head, and fast pointer also, which is let's make it in one line only. Slow pointer, I can say fast pointer, I can say previous, right? And slow is pointing to head, fast is also pointing to head, and previous is null. So we can say like this. And now guys, why I am making a fast first half reverse, right? So just because of this, because I need to find the mid of the linked list anyway, right? In both the case I need to find the mid of linked list. So while finding a mid of linked list, I can reverse the first half in between in that particular loop only, right? So how we can do this, you can see here, like we can say while fast and fast dot next, we can say fast should be fast of next. So by this we can find the half of middle of the linked list, right? We can reach to the middle, but in this loop only we can reverse the first half, because we know that this is going to run n by 2 times. So we can say slow. First of all, we can say let's store. We can say new node, or we can say next node of slow. After that, we can say slow dot next should be equal to which one? Previous, and previous now equal to slow, and slow now equal to next node. I have you know this the concept of reversing a linked list. So I'm just reversing the first half of the linked list in this particular loop only. So once I reverse the first half, what I can do, I can say, okay, I have the first half, I have the second half on also. So now I can say traverse while your slow is not equal to, or while your slow exists in Python, you can do like this, and you can say result. Let me make it a result variable here, which is now 0, and we can say result should be maximum of either result or slow dot value plus previous dot value. And why previous? Because previous is nothing but my half. Let me tell you in detail. So I can say slow is now, if that particular example 5421, my slow is now storing 2 and 1, and my we can say this particular previous is now storing 4 and 5, right? So now I can say 2 plus 4 and 1 plus 5, right? So once after done this thing, I can say slow is equal to slow dot next. I can keep moving, and we can say previous is equal to previous dot next. All right, and after that we can return our result, because we know that result will be having a maximum right now. And you can see that all the test cases are passed. So let's try to submit this code also, and it is successfully got submitted, right? So we have successfully solved this particular problem. Now let's move to the another programming language that is nothing but we can say like C++. And here what we are going to do, first of all, we are going to find create a list node. Let's say head, which is equal to, not head, let's say slow, which is equal to head. Then again we can say fast, which is also pointed to head. Then list node, we can say previous, which is nothing but null right now, right? Okay, so once with this is done, we are going to find the main. So we can say by fast is not equal to null ptr, or while fast dot next is not equal to null ptr. You have to keep moving, right? And here we can say fast should be equal to fast, let me write equal to fast dot next, and after that we can say reverse the linked list of first half. So we can say let's store list slow next point. So list node next node is going to be equal to slow dot next. We have stored the slow dot next, so we can use something in slow dot next. Slow dot next should be equal to now previous, and previous equal to slow, and we can say now slow should be equal to next node. Fine, now we have done the reverse. Now once we have done the reverse, now what we are going to do, we are going to traverse till end. So we can say while slow is not equal to null ptr, you can keep moving. So we can say result should be equal to maximum of result comma slow dot val plus, we can't use a dot right here in C++, we have to use this particular symbol. We have done a lot of mistake here. Then we can say fast of this particular thing, and also we have used here, oh god. All right, so fine, let's solve this particular issue. Sorry for this guys, right? So we can say slow of next, slow of val plus fast, not fast, previous dot previous of val. Once we are done this thing, we are going to move slow 1 point ahead, slow of next, and fast also, not fast, previous also, we can say previous of next, right? After that we can return our result, and we haven't declared result, so we are going to declare result as well, so which is not equal to initially result is equal to 0. Now let's see whether we have mistake that particular mistake of dot symbol. Yeah, we have some here, right? Let me see what is the error. Member access with null pointer of type list. Okay, so we have to use and here, right? We can't use a or operator. Fine. Now let's see whether it's fine or not. And here we go, guys. All the test cases are passed. So let's try to submit this with the language as well. And you can see that it also got submitted, right? And now let's move to the last programming language, that is Java. And here what we are going to do, we are going to say list node. First of all, let's take a fast pointer which is head, then list node slow pointer which is node slow, which is also equal to head, and let's take a list node which is equal to previous, which is equal to null, right? So we can write null. Now let's say while fast, let me write while fast is not equal to null, and while slow fast of next is not equal to, note here I have to use dot, Whenever you use a different programming language, you might confuse, right? And that's happening with me. So I can say fast is equal to fast of next dot next. I can say reverse the first half, so I can say list node. We can say next node. I'm going to store the next node of slow. After that, I'm going to say slow dot next should be equal to previous. After that, I can say previous should be equal to slow. Now I can say now slow should be equal to whatever the node I have stored, right? So once this is done, we are going to say declare a variable result, which is going to be result of it. After that, you use a while our this slow is not equal to null. You have to keep moving and you have to say result should be equal to maximum of result, comma, not maximum. Here we have to use math dot maximum. We have to use this math library. After that, we can say result either result or slow dot val plus I can say previous dot val. Once this is done, we are going to move one step ahead. So slow should be equal to slow dot next, and previous should be equal to, let me write here next, previous should be equal to previous of next. And after that, we can return this particular result. So let's run this code and see whether it's working fine or not. And I got an error. Why is it so? It's not. Okay. I was using a pointer here. This time I'm making a lot of mistake, right? We can't do pointer in C plus Java. We don't have this particular, right? Fine. Now let's see what we are getting. I don't want to get an error in Java, but I have got two, and it's not previous is equal to null. Okay, this is the typo mistake. Do we have any more error in Java? Let's figure it out. You can see that all the test case passed finally. Now let's say to submit this language, this code with this language, and I hope this will get submitted, right? So you can see that we have successful with a C++, Java and Python, right? So guys, if you understood everything, then well and good. If you still have any kind of doubt, any kind of you can say you could not able to find understood any kind of line or anything, then you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.